Seaborg, evolutionary biologist and president of the World Rainforest Fund. And I'm going to continue with my Pachamama hypothesis, how many aspects to the hypothesis, but right now I've been speaking about how life made the atmosphere better for life. And in this respect, my hypothesis overlaps with the Gaia hypothesis. In other aspects of the theory, it's much more general than the Gaia hypothesis. In fact, the Gaia hypothesis is really a subset of the Pachamama hypothesis. So I'm going to talk about today, because I talked last time about greenhouse gases, how Earth created the high oxygen. In the beginning of life and of Earth, there was less than 1% oxygen in our atmosphere, and life has brought it up to 20%. And this started with the evolution of photosynthesis 3.5 billion years ago, which was use of sunlight, but not to produce oxygen, but it did produce energy. So that was the first step. But that wasn't the production of oxygen, but that was photosynthesis, the use of light energy. But its end product was sulfur, but it still did produce the carbohydrate, which is what photosynthesis evolved for. Then 3.4 to 2.9 billion years ago, we don't know the exact date, oxygenic photosynthesis evolved, that is, photosynthesis that produces oxygen. And this was to make carbohydrates for the plants, and then the rest of it, well, at this point, for cyanobacteria, a kind of bacteria. And then that goes on up the food chain as they are eaten. Photosynthesis produces the energy, the carbohydrate that runs the whole food chain. Okay, now, so at this point, when uh, oxygen producing photosynthesis evolved, then was the Great Oxygenation Event, as it's called, or the GOE, when oxygen levels greatly increased, but still only about 1%. And then over time, as plants evolved and more photosynthesizers evolved, first phytoplankton, then plants, slowly photosynthesis brought it up to 20%, but that wasn't enough. Producing oxygen wasn't enough because oxygen gets combined with other elements like iron and other minerals, manganese, magnesium, and methane, the greenhouse gas. So what organisms had to do was bury carbon that did not have oxygen, and they buried it by the mechanisms I talked about yesterday. In other words, phytoplankton sinking to the bottom of the sea, trees getting buried, animals getting buried. Some of that takes out carbon that has oxygen and controls temperature that way by controlling greenhouse gases, which have carbon. That's carbon dioxide and methane, the main greenhouse gases. But some of it took out carbon that had no oxygen, and that increased the oxygen. So that's how the oxygen got this high. And there was a period which is about 375 to 275 million years ago, from the Permian, actually Carboniferous period to Permian period. And that was when oxygen really, really got high, because a lot of carbon without oxygen was buried in swamps, these big tree-like things called club mosses and other things got buried. And oxygen was so high that things that were limited by oxygen in their size, like insects and millipedes and centipedes, got very big. There were 2-foot wingspan dragonflies and many foot long 5-foot centipedes and millipedes. there's a lot more fire too, because fire depends on oxygen. So that'll be enough for today. I'll pick up more next time. Thank you for your attention.